When you're scanning or sampling, also when you're doing drill holes, you get points. The points may be hanging in space, like my fingertips, but what you need for manufacture and for a whole lot of other uses is to have a smooth surface that interpolates, goes through the tips of the fingers in this case, goes through the data, but is sort of smooth in between. And so these algorithms enabled one to find the smooth surface very fast. If you used a conventional approach, then if you had n points, the time taken or the number of operations would be order n cubed. If you use these algorithms, it's n log n squared, which is very much faster and enables you to do data sets with 500,000 points in a reasonable time, whereas if it's n cubed, 500,000 points you can't do. We worked our way towards it. We were pulling some related math from PDE solvers, pulling that across. There was one particular aha moment where we thought, okay, let's do an implicit surface. That means have a function that is 0 on the sampled points and is equal to an estimate of the distance from the sample point off, and you fit a function of 3 variables to that, and then you extract all the points where that function is 0, and that gives you the smooth surface. So there was a bit of an aha moment when we did that, and then we had to sit down and see if it worked, which took a few months, but then we knew we were onto something that worked quite well. I don't know the number of artificial limbs, but it must be in the tens or hundreds of thousands that have been manufactured this way. So they scan the person's stump, they manufacture a positive, and then they put a negative out of that, and the negative fits well over the stump. So it's obviously going to be a lot more comfortable when you're actually helping people. That feels really good and fairly rare for a mathematician to actually directly or fairly directly help people. There's definitely room for improved algorithms, and all real-world data is noisy, so we should be doing more about the noise than we actually are. I think we're still doing pretty well compared to others, but I think we can do better. Yeah.